Hello and welcome. Today we're going to be continuing our series in machine learning and data science. We started this series yesterday. For the benefits of the people that could not follow yesterday, today we're going to just quickly revise what we did yesterday. And we're going to move into the installation of our Anaconda. Anaconda is going to be the tool that will house our Jupyter notebook and enable us to run this whole application. So to start with, I'm going to quickly share my screen. Okay, so we are there now. So we're looking at data science, and in data science, we are actually going to be able to make decisions and make predictions using what we call predictive causal analytics, prescriptive analysis, that is predictive plus decision science, and machine learning. In data science, we use the knowledge of machine learning to make predictions. We use it to take decisions, advise our CEO on what product are people buying from our company. Are they buying the aloe vera type of soap, or are they buying the normal soap? So when we're able to fetch this data, we'll be able to advise the company, and the company will put more of its resources in that very product that sells more. So data science will help you collect this data, evaluate your customers, know what they need, and using machine learning, you'll be able to predict what is needed to be done. And we're going to be able to explore this using machine learning. So, like I said before we started this series, that our company is going to be employing a junior developer. By the beginning of next week, our new website will be up on Tclassified.com. So if you are interested in the job, you can head over to Tclassified.com. You will see careers and vacancy. You should be able to apply there. So if you apply and we find out that you can do the job, then we'll be able to employ you. So from next week, Monday, we'll start collecting the applications and we'll conduct a series of interviews. So having a knowledge of machine learning will be an upper hand for you in getting the job, because we will need to employ somebody that can deliver for us. And we are diversifying into many angles in software development. So your knowledge of machine learning is going to be useful for you, and that is why you have to follow up the class or get to learn about machine learning and data science. Okay, so how does data science work? When we talk about data science, how does it work? Data science involves a plethora of discipline and expertise area to produce a holistic, thorough, and refined look into raw data. Data scientists must be skilled in everything from data engineering, that is number one. For you to do very well in data science, you have to have skills in data engineering, mathematics, statistics, advanced computing, and visualization, in order for you to effectively sift through the model masses of information and communicate only the most vital bits that will help drive innovation and efficiency. Now, what are the processes that the data science takes in achieving his goal? What are the processes? Number one, there has to be data capture. If I'm looking at Tclassified.com on YouTube, I should be able to know how many viewers am I having capture. Is that clear? I need to know how many viewers am I having on my YouTube channel. I need to know how many likes. I need to know the likes. Where are they from? Is it my video on data science, or is it my video on Python? So I should be able to capture this data. And one way of capturing, when you get to the YouTube analytics, you're going to see some data there related to what I've just said, if you're looking at YouTube audience. So depending on what audience you need to fetch the information for them. If you're looking at customers that access your website every day, you should be able to have an analytic that collects such data. So data capture is very, very important. So when you get such data, you need to enter it. If it's in form of CSV file in Excel, you need to know how to enter it. That's why we talk about data entry. So apart from capturing your data from your website, there are also data that is available everywhere. If you're capturing data for health, there are already data that are there, which I'm going to give you. If you go to Kaggle, and some other websites, they have repository for plenty data that you can use to make any form of machine learning analysis. Then there is also data reception and extraction. You need to be able to access this data and receive and extract them. Then secondly, we talk about data warehousing, data cleansing, data staging, data processing, and data architecture. So under this, you are able to, the data that you've captured, you should be able to clean it up in order to feed it into a Python model so that it will give you what you want. So data cleansing is very, very important. We are going to use Python to train you on how to do data cleansing, warehousing, staging, and the rest of them. Then the third process is processing, which includes data mining, clustering and classification, data modeling, data summarization. So in processing, this is actually where you build your model and let your model do the work for you, which we'll also do in practical terms. Then we'll look at communicate, data reporting, data visualization, business intelligence, and decision making. This is when, from what you've done so far, you're able to put your data in form of table and charts so that somebody can visualize this, your data, and be able to read out meaning from it. So from there, somebody can make good business decision. And finally, analyze. So under here, you have to do what we call exploratory and confirmatory predictive analysis. And that is when all your work is done and you're able to visualize your work and you make all these other things under analysis, including regression, data mining, and qualitative analysis. So now let's look at big data. As a data scientist, to be able to differentiate between data science and big data or data. Big data. Before you are able to say that this data is big data, that data has to be so large. And not just so large, it has to be in numbers, in great velocity. That's what we call big data. I can collect the data of all the students in Tclassified. That is not big data. Because in Tclassified, you have maybe maximum 50 students for software and for computer operations. So 50 students data cannot be a big data. When you're talking about big data, you're talking about how many people are accessing YouTube every day. You're talking about millions of people, isn't it? And every day, new people are going there. So the data number is increasing exponentially. Is that clear? Can you differentiate now between data and big data? Joshua, can you differentiate between data and big data now? So when you're talking about big data, you're talking about volume and the velocity of increase. You understand? It's constantly increasing. Data of people that are in Tclassified is almost constant, isn't it? Maybe once in 1 week or 2 weeks, new people will be added up. But when you're talking about big data, you're talking about plenty data added. Is that clear? And data scientists are able to do this using machine learning. They're able to analyze such data. Is that clear? But statisticians, they are very good with the normal data that you have. Can you see the difference? Data scientists are able to take on big data and still run the same analysis, produce graph, produce bar chart, and everything for you. Do we get the difference? And that's why we say big data is also data, but this time around, it has what? Huge size. It has what? Huge size. Big data is a term used to describe a collection of data that is huge in volume and yet growing exponentially with what time is growing every day. So whenever you have a huge data that is growing every day, we call it big data. Is that clear? As a software engineer, you're supposed to know what big data is. Is that clear? And you should be able to differentiate it from the normal data that you collect. Okay. So in short, such data is so large and complex that none of the traditional data management tools are able to store it and process it efficiently. Can you see that? The data is so complex that the traditional tool that you would have had will not be able to take care of it. But with data science, you can be able to take care of such data effectively. Is that clear? And that's why big companies like Google and Facebook, they make a lot of profit because they use machine learning and they use their data science ability to collect the information of everybody. Have you not noticed that when you go online, if you ever try to search for iPhone, when you go online and open your Google, you will start seeing iPhone adverts. Who has noticed that? Without going to iPhone, you will not start seeing the advert. Just check it on your phone. That's what is happening. You understand? Because they're able to collect, they know what you've searched for. You understand? So with what you search for, they're able to visualize it and see that this is what you always wanted. So they will send that which you always want to you. And by doing that, you buy more. So if they are running adverts for that company pay Google much because Google is actually doing the work by pushing their product to you. So you end up buying that product. And that's why people pay big companies like Google and Facebook to run adverts for them. Because these big companies, they have all the data they need about you as a customer. They know how to use data science and machine learning to study, you understand, extrapolate, analyze, and know what you want and send something to you. And they make more gains and everybody enjoys. Both the people that are running the advert, because if you are to run it on your own, you might not even have enough data to know what people want. But Google, Facebook, all of them, they have enough data about everything. Okay, so move to the next slide. What are the characteristics of big data? Why would you see a data now and say that this data is big and say that this one is not big? Number one, the volume must be very large. Like I said before, there has to be variety. It shouldn't be only name or only height that is speaking. It has to pick different information about a particular subject. If it's about human beings, you'll be able to pick the height, the complexion. You understand? Everything. More, the data field has to be many, variety. Then we'll talk about velocity. Velocity is rate at which more data is being added to the data that you already have. That is velocity. Then variability, it should be changing. The data is always changing from time to time. Okay, so that brings us to artificial intelligence. Artificial intelligence. What is artificial intelligence? Artificial intelligence, the abbreviation is AI, and it refers to simulation of human intelligence in machine. It simply means making machine to behave like human being. Artificial intelligence. Human beings are supposed to have intelligence, isn't it? You take that intelligence, you give to machine. Machine now start acting like a human being. A machine is able to learn, go to school and learn just like you, and be able to use the knowledge from what he has learned to do things. That is artificial intelligence. So when a machine gets into human intelligence, we call it what? Artificial intelligence. So it's able to now think like humans and mimic their action. So that's why you see some robots, they can do what you can do. So the term may be applied to any machine that exhibits traits associated with human mind, such as learning and problem solving. So once a machine can learn like a human being and solve problems like a human being, that machine is said to have artificial intelligence. Is that clear? So in machine learning, you're going to find out that you teach a machine using data. How does data science relate to machine learning? You use enough data to teach a machine something. So once the machine learns, the machine will have the sense and start behaving like a human being. It's able to predict and solve problems like human being. So with enough data, you can coach a machine to start behaving like human being. Just like you, when they born you, you don't know how to do anything, isn't it? When you start going to school, what the lecturers and the teachers teach you, they are pouring data into your head. They are pouring what? Data. At some point now, you start behaving well. You can handle computer. You've learned. So in that same way, if you collect this big data that we are talking about and feed it to machine using a very good model, the machine will be able to also learn. When the machine sees a cat now, from what the model we are going to run, you're going to be able to see that when a machine sees a cat, it will tell you that this is a cat. If it sees a dog, it will tell you that it's a dog, because that machine has learned. How does it learn? By supplying enough data to it. That's when we talk about big data. Is that clear? You get this data of cat and rat. How are you able to differentiate between a cat and a rat? It's because you've been seeing it every time, isn't it? In that same way, if you snap the picture of plenty cats and picture of plenty rats and feed it to a machine will be able to differentiate between a cat and a rat. And that is what we are going to be learning in this very, very interesting aspect, of course. So let's move to the next slide. Artificial intelligence is based on the principle that human intelligence can be defined in a way that a machine can easily do what? Mimic it and execute tasks. From the most simple to those that are even complex. So we're going to start from simple things, like telling a machine to identify between A, B, C, D, 1 and 2. Then the machine will now be able to tell you, when it sees a cat, it will tell you this is a cat, this is a rat, or this is a dog. Okay, are we still there? The goals of artificial intelligence include learning, reasoning, and perception. Those are the three main things. You make a machine to learn, the machine should be able to reason, and the machine should be able to transfer this reasoning and do what we call perception. Other examples of machine learning with artificial intelligence include computers that play chess. Like I told you yesterday, computer is able to play chess and do self-driving car. I gave you guys the example of Tesla. Have you heard about Tesla? Owned by Elon Musk. Do you people know who is Elon Musk? You know Elon Musk that has Tesla? His cars can drive themselves. So those cars are actually machines, isn't it? That are trained now. They have the wisdom of human beings. They can drive themselves by themselves. And that is why we call them, that's why we call it machine learning. Each of these machines must weigh the consequences of any action they take, as each action will impact the end result. In chess, the end result is winning the game. Whereas in self-driving cars, the computer system must account for all external data and compute it to act in a way to prevent collision. That is the end goal for a self-driving car, you understand? You train the car so that when it's driving, when it's going, if it sees a wall or another car, it will not collide. It will not do what? Collide. So how does he know that? He must have fed that very car with enough data of pictures of what it can see on the road. So that when he sees a car like itself, it will dodge it to avoid collision. Is that clear? So it's very, artificial intelligence is very simple. Just collect enough data about what you want that machine to know, feed it to it. As the machine is seeing this, you know that this is a human being. Whenever I see a human being, I should not collide with a human being. Whenever I see a car, you understand? And that's why we say big data has to be, there has to be variety. It's not only one car. If you snap only Pojo and go and show, if the car sees a camera, it will hit it, go on. Is that clear? So you must have had pictures of different cars. So the data we are talking about is not 1, 2, it's not 3. You understand? The data has to be so big. That's why I taught you about big data. That's why I taught you about what? Big data. So you feed enough data to the machine so that the machine can be able to classify. Know that this is a car, this is a human being. When I get close to it, I should not collide. Very important. And that brings us to machine learning. So machine learning is an aspect of artificial intelligence. Just like deep learning is also an aspect of artificial intelligence. There are two approaches that you can use in going to artificial intelligence. You understand? You can use machine learning, you can use deep learning. You can also use other ways. But machine learning and deep learning are the best ways to go about it. And that's why we are concentrating on machine learning and deep learning. There are other support vector machine and so many other things we can do, which are methods in machine learning. But the method in machine learning that we'll be concentrating on will be deep learning. Deep learning is the best approach to that. Okay, so what's this machine learning? Machine learning is an application of artificial intelligence, like I said before, that provides systems with the ability to automatically learn and improve from experience without being explicitly programmed. So in machine learning, the machine learns from a lot of data. You don't have to write an explicit program. Just with the data, enough data and model, you should be able to learn. Machine learning focuses on the development of computer programs that can access data and use it to learn for themselves. Okay, the process of learning begins with observation or data. So like I said before, learning, anything in machine learning has to start with data. That's why we learned about big data first. You have to have enough data because it's from the data that the machine learns. Such as examples, direct experience or instructions, in order to look for patterns in data and make better decisions in the future based on the examples that we provide. The primary aim is to allow the computer to learn automatically without human intervention or assistance and adjust actions accordingly. So there are two major types of machine learning. We have what we call supervised and unsupervised learning. In supervised learning, we have what we call labeled data. You must have seen the data, known them, and labeled them. So the work of the computer is now to take a classification. Say you have a classification of cat and rat already. You already know it's cat and rat. So you teach the computer in order to identify that these are cats and these are rats. That is supervised. Under unsupervised, you've not classified the data. The computer looks at the data and is able to identify some characteristics. So the computer will not classify some into one angle, classify the other one, and classify the other one. So without the label, computer is able to look at that data, identify some of each features, put the ones that have similar features to one class, put the ones that have similar features to another class, and put the one that has a similar feature to another class. That is unsupervised. Okay, so to look at it one by one, say that in supervised learning, this approach basically teaches machine by example. During training for supervised learning, systems are exposed to large amounts of labeled data. That word, that's the key word for supervised learning, labeled data. For example, images of handwritten figures are notated to indicate which number they correspond to. Given sufficient examples, a supervised learning system will learn to recognize the clusters of pixels and shapes associated with each number and eventually be able to recognize the handwritten numbers. Able to reliably distinguish between numbers 9 and 4, 6 and 8. So after using supervised learning, you are going to find out that computers should be able to locate 9 and 4 and distinguish between them when they see it, just like you can do as a human being. However, training this system typically requires huge amounts of labeled data, with some systems needing to be exposed to millions of examples to master a task. So under unsupervised learning, in contrast, unsupervised learning tasks algorithm with identifying patterns in data, trying to spot similarities that split that data into categories. So in unsupervised learning, computer is able to identify what? Similarities in features of data and is able to split the data into categories by itself. It's not you that will do the labeling. It will split it by itself. An example might be Google News. You can see that's what Google News uses. Google News grouping together stories on similar topics each day. So Google is able to take up stories that it sees each day and is able to classify them based on similar topics. So that when you're reading this one, it will send you similar topics so that you go read it more. By so doing, it's engaging you more on Google products. You're always there because you're seeing what you like on Google. Whenever you go to Google, you see what you like because it's able to use the predictive nature or ability of the machine learning to suggest to you similar topics as you want. Okay. The algorithm isn't designed to singular specific types of data. It simply looks for data that can be grouped by its similarities or for anomalies that stand out. So finally, we'll come to the end, which is what? Deep learning. So like I said, deep learning is a form of machine learning that builds its model looking at the neurons in the body. So this one mimics just the human way of thinking or human's way of processing data. So what is deep learning? Deep learning is the artificial intelligence AI function that imitates the working of the human brain. So in deep learning, it imitates the working of the human brain, and that's why deep learning is the most efficient way of doing machine learning, depending on the type of data that you have. So it imitates the working of the human brain in processing data and creating patterns for use in decision making. Deep learning is a subset of machine learning. Like I told you, there are other ways you can do machine learning. You can use what we call support vector machine. There are many other ways. SQLearn, plenty of them. But deep learning is the subset that is very, very powerful. In artificial intelligence that has network capable of learning unsupervised from data that is unstructured and unlabeled. So with deep learning, you can do a whole lot of things. Also, also known as deep neural learning. You can also call it deep neural learning or deep neural network. Those are other names that you can call deep learning. So how does deep learning work? Deep learning has evolved hand in hand with digital era, which has brought about an explosion of data. Now you can get data of almost everything you want, plenty of them in all forms and from every region of the world. This data, known simply as big data, that's what we call this type of data that is so much, is drawn from sources like social media. That's where you can get big data from social media, internet search engines like Google. That is where you get big data. Your e-commerce website platform, you can use it to get some good data. Online cinemas and amongst others. This enormous amount of data is readily accessible and can be shared through fintech applications like cloud computing. So what are the importance of deep learning? Deep learning unravels huge amounts of unstructured data that would normally take humans decades to understand and process. Without deep learning, it would have taken you how much time to process data? Decades. You know what a decade is? 10 years. Something that would have taken you decades to process and understand. With deep learning, you can do it. It will plot the graph. In data science, that's what we're going to be learning now. How to immerse those amounts of data and plot it into graphs and charts that people can understand, just like statisticians do. You understand? But statisticians, they cannot work on big data, isn't it? But you as data scientists, you can do what? Work on big data. And those are the tools that we're going to be using. And using the simple language of what? Python. Using the simple language of what? Python. You should be able to handle machine learning, deep learning effectively. Okay. So having done this, we'll then move straight to the work of today, which is downloading Anaconda. Like I said before, Anaconda has all the tools that you need for you to write your to do your machine learning and your deep learning effectively. So I'm going to go to www.anaconda.com. So you can just get to Anaconda, then to individual edition, because that's what we want. But let me just get to www.anaconda.com. So we did it yesterday. If you did not do it, please follow up now. So once you're in anaconda.com, that's where I am now. www.anaconda. Click on Get Started. So once you click on Get Started, you see this place, the road, Install Individual Edition. Click on it. So once you click on it, it will lead you to this other page where we have your data science toolkit. Can you see where the road download? Click on Download. So once you click on Download, it's going to take you to the installers. Most of you here are using Windows. So if you're using 64-bit Windows, click on this. If you're using 32-bit, click on it. If you're using Mac OS, click this one. If you're using Linux, so depending on what you are using. So I'm using Windows 64-bit, so I'm going to click here. And I clicked here yesterday, so it's already downloaded. So I'm going to move straight to installing. Did everybody download yesterday? So if you did not download yesterday, please download now so that we can install. Brother, have you downloaded? Okay, so download so that all of us can install together. So because I clicked here yesterday, my download should be in my download folder. So I simply go to my download. So my Anaconda should be here. So you can see this is my Anaconda. You can see the Anaconda for Windows 64. So I did this yesterday. Okay, so I should be able to double click on this and get it installed. I didn't actually check what the megabyte or what the gig was yesterday when I did it. You finished your own. Check your own. What was it? 466. Me, I'm having 470. So my own also fully downloaded. So this is my Anaconda here. So we're going to do the installation today. So let's install Anaconda because that's what we're going to be using to run our machine learning and data science. Whether it's machine learning, data science, artificial intelligence, deep learning. With the simple tool of Anaconda and with your knowledge of Python, you should be able to do that. So I'm double clicking on the file so that I can get it installed. So please get it downloaded and we install it. So let's install Anaconda now. Okay. So you can see that it's installing. Say please wait while setup initializes. So it's installing currently. Okay, so you see this come out. So I'm going to click on next. It's going to ask me whether I agree to the terms. I'm going to click I agree. So am I using it for just me or all users? I'm using it for just me. So I'm going to just go. So where do you want it to be installed? Under user Anaconda 3. So I'm going to click next. So it's a simple installation. Advanced option, add Anaconda to path variable, register Anaconda in my default Python 3.8. Okay, so I already have Python 3.8. So let me leave it registered with that. So I click on install. So I'm going to leave it, it's going to fully install. So that's where we're going to be stopping today. So get your installation done. So I'll open it up and see that it's working so that we'll continue from there. Thank you. God bless you.